Alright, now we're going to use a differentiation technique that's kind of weird because it's handling a function that we haven't quite seen before. We've seen functions like x cubed and we've seen functions like e to the x. In this case, x is in the base while we have a number here. And in this case, x is in the exponent while we have a number, e, here. This has the x both in the base and in the exponent. So what do we do in this situation? What we're going to do is we're going to start by taking the ln of both sides. So we have ln of y equals ln of x to the negative x squared. The reason I'm doing that is because I want to bring this negative x squared down as a coefficient per my log rules. So now I have negative x squared ln of x. That negative x squared was brought down in front, and now I can take the derivative of both sides. It is this process of taking the ln so as to bring this negative x squared down in front to give me a product that makes this process possible. So I'm going to take the derivative of both sides. The derivative of ln of y is 1 over y. Don't forget your implicit differentiation rules would say that anytime you take the derivative of y, you got to tack on a dy dx. How about the right-hand side? Well, there's a product rule going on here. We have negative x squared times ln of x. Let's take the derivative of negative x squared. That would be negative 2x, leaving the ln of x alone. And now we're going to say plus, or rather minus. We're going to leave the x squared alone and take the derivative of ln of x. The derivative of ln of x is 1 over x. There's a little bit of cleanup that I can do over here. I'm going to do two things, actually. I'm going to multiply this y over from the left to the right. So I'm going to multiply both sides by y. Whole thing times y, so this now cancels. And I'm going to say, you know what, x squared divided by x, that's just 1x, or x to the 1. So that's going to give me a final answer of negative 2x y ln of x minus xy.